Welcome to From Noise to Signal, a practical guide to mastering EMI. This video focuses on selecting and applying common mode chokes for DC power and data lines. Electromagnetic interference, or EMI, is an unavoidable byproduct of high-frequency electronics. Failing to control EMI can lead to costly redesigns, poor signal integrity, and reduced product reliability, as shown by the measurement exceeding the standard limit. The engineer's solution is the common mode choke, or CMC. A CMC is a filter that blocks high-frequency common mode noise while allowing the desired differential mode signal or power to pass through unaffected. The first critical choice is between bifilar and sectional winding. Bifilar windings are best for data lines as they offer high symmetry and low leakage. Sectional windings are ideal for power lines, providing higher isolation and differential mode filtering. When decoding the datasheet, the key takeaway is to match the impedance peak to your noise frequency. This peak is the choke's noise-stopping power. Ensure the impedance remains low at your signal's operating frequency to avoid distortion. Next, consider rated current and DC resistance. Exceeding the rated current is a thermal limit that causes overheating and performance reduction. Minimizing DC resistance is crucial for efficiency, as it directly causes voltage drop and power loss. Selecting the right tool for the job means matching the choke series to the application. Use sectional winding for DC power, bifilar for high-speed data, and a balanced design for mixed power and data applications like PoE. The selection blueprint starts with defining your design constraints. You must determine the required rated current, working voltage, acceptable voltage drop, available space, and ambient temperature. Step 2 is selecting the winding style, bifilar for data lines and sectional for DC power lines. Step 3 involves matching the impedance curve by identifying the noise frequency and ensuring common mode attenuation while verifying differential mode transparency. You can accelerate your selection using RedExpert, an online platform. It helps you filter by constraints, compare the performance of multiple components, and visualize real-world effects like temperature derating. Let's review a real-world case study. The problem involves an industrial machine control system with a flickering LED screen due to noise on the power supply. The goal is to find a common mode choke to suppress this noise, given the design specs. Following the blueprint, we select a sectional winding choke based on the DC power line application. 2 candidates are viable, meeting the current, voltage, and voltage drop constraints. The selected choke suppresses the noise, eliminating flicker, and the product passes certification. To master EMI, always characterize your noise first, match the winding to the line, mind the voltage drop, and leverage modern tools like RedExpert. For a deeper dive, explore our full range of EMC components and design tools.